Good morning, dear students. Now, today we will discuss one more purification method, that is the thin layer chromatography. And the abbreviation form, the short form of it is TLC, thin layer chromatography. A type of adsorption chromatography which involves separation over a thin layer of an adsorbent coated on a glass plate is thin layer chromatography. When we started chromatography, I told two types of chromatography, basically adsorption and partition. So column chromatography, which we have discussed, that is partition chromatography. Paper chromatography is adsorption chromatography. Thin layer chromatography is also adsorption chromatography. Thin layer adsorption chromatography is very similar to paper chromatography. In that, any stick, wooden or plastic, very thin stick, on that the paper, chromatographic paper or special filter paper or thick tissue paper is used. But here the thin layer of silica gel or alumina is prepared. Otherwise, all other method is nearly same as paper chromatography. A thin layer about 0.2 millimeter thick of an adsorbent like silica gel or alumina is spread on a glass plate of suitable size. The glass plate is also very thin and it's not taken very thick, of nearly suitable size. That means, what about the jar, the outer container? According to that, the glass plate is taken and on it silica gel or alumina is spreaded, right? As we are putting the color on some surface, or as we are putting the butter on a bread, like that the silica gel is prepared and is spreaded, or even alumina is spreaded on. So this is the construction of the thin layer chromatography plate, which is called thin layer chromatography plate or just chroma plate, right? So like this, a very thin glass plate is taken and even on it just a layer of 0.2 millimeter, right? Very thin layer is spreaded on it, and then the solution of mixture is applied. Whatever the solution of a mixture which we are going to separate, that solution of mixture in very small amount is applied as a single small dot about 2 centimeter above the one of the end of TLC plate, right? So here this is the TLC thin layer chromatography plate, and here we have to mark one line which is called baseline, and from baseline above it, nearly 2 centimeter above, the solution, that is the mixture, is to be plotted. We have to put the mixture here, and then this plate is kept in a jar where the baseline only should touch the solvent. So solvent should be according to that much only, it should not come up to here, right? And which is containing the eluent. So what happens after some times, we can see that along with the solvent, when solvents start raising on the silica gel, this is the liquid phase and this is the solid phase. Along with it, up to certain extent, this mixture will also start adsorbing. Adsorbing, that means will start on the remains on the surface of that particular solid phase, and up to its degree of rising, because all the components are not having similar degree of the rising, or we can say similar degree of the adsorption. So as per the degree of the adsorption, it will start rising along with the solvent, right? And then what is to be done? The sample which is raised and the solvent which is raised, both are measured. So this plate is to be taken out and a chromatogram has to be prepared. Chromatogram, that means determination of the rising degree has to be taken. So from the baseline up to the rise of the sample, see, this is a faded up to here it has, and now here onwards it is not moving. So this is considered as X, and from baseline up to the solvent is still adsorbed, and so it goes higher than the sample, and this distance is Y. So with the help of this chromatogram, the separated compounds by the eluent, the solvent containing eluent is there. So by the help of the eluent, the separated compounds is measured in the term of retardation factor. Retardation, that means the solvent is still moving higher and higher, but now this sample is left back. It is retarded. It is left back, and so we will be counting retardation factor. Or we can say retardation means the value of the degree of the adsorption. So how it is measured? Retardation factor is equal to distance moved by the sample from baseline, that is X, divided by distance moved by the solvent from the baseline, Y. Always the solvent will be moving greater than the substance. That we have to keep in our mind. This is the thin layer chromatography. Now here what happened? When the spots of color compound is there, we can easily see that how far they have rised, right? But if the spots of colorless compound is there, then it is invisible to us. And if they are fluorescents, then they can be detected by putting the plate under the ultraviolet light. So if colorless spot is there, but if we know that yes, they are fluorescent compound, then this plate is kept under the ultraviolet light and we can see the color, what is the compound having that color. Sometimes even happens that, sometimes even by the effect of ultraviolet light also, color spots are not seen. Some colors are there that even by the ultraviolet light also they are not seen. Then another detection technique is to be applied. So the another detection technique is applied, that at that time the plate is to be placed in a covered jar. The TLC plate has to be kept in a covered jar, and that jar is containing crystals of iodine, and iodine is brown in color. So one jar is to be taken in which iodine crystal is kept, and then that plate as it was kept here, again it is to be kept like this in the crystal of iodine and has to be covered. So as soon as the jar will be covered, the sample will react with iodine, and iodine is brown in color. So the sample will acquire somewhat brown color. That means adsorption will take place. On the surface of that substance, the iodine color will be adsorbed. It will not completely absorb up to the core. So spots of the compounds that adsorb I2, that is iodine, will turn brown and then will be seen, and it can be determined. Even the compound is not colored or not fluorescent. Now still what happens? Sometimes the substance is not colored, not fluorescent, also not reacting with iodine. Then what happens? Then an appropriate compound is to be taken which can be sprayed on the plate. So in all the, suppose the condition is not favorable for colored compound or fluorescent, it is not fluorescent or not reacting with iodine, then some appropriate solvent is to be sprayed. It should be sprinkled on this plate, right? And which can be then detected if they carry the color of by spraying the compound. As for example, amino acids. When amino acids is to be detected, then by spraying the plate with neem hydride solution, it is possible. So whenever the testing of protein is to be done, protein contains amino acids. So at that time, neem hydride solution is definitely used, so only the amount present as amino acids can be detected, right? So various detection techniques are allowed in TLC technique, that is thin layer chromatography technique, so that the organic substance can be detected. And organic substance are highly in use in daily life, industrial life, right? Economically, and that is why all this technique has to be understood, so that we can find out that what amount of material is present, right? In our textbook, I have just drawn a simple figure, even this and in the other chromatography method also. But our textbook contains all the figure in a very proper manner. So you can go through the figures from the textbook also. And you can get proper wide idea. So I am also sharing the animated videos which you can also go through it. Right? Thank you.